Okay, let's look at some more examples where everything is all mixed up and we have to decide what to do when. So for the first one, I see a binomial. I do see cubes involved. However, I must check for the GCF first. Now there's a GCF of 3 between the 27 and 15, and also they have an x in common. So I'm definitely going to pull out a 3 and an x. And since it starts off with a negative, remember when the problem, the leading coefficient is a negative, we tend to pull that out. So I'm going to take a negative 3x out. That's going to leave me with negative 27 divided by a negative 3, which is a positive 9. X cubed, take away one of the x's, I'm left with x squared. Negative 15 divided by negative 3 is a positive 5. Remember, signs change when you pull out negatives. And there was only one x and I pulled it out, it's gone. Now 9x squared plus 5 does not have any more GCFs in common, and it cannot be factored any further, so we are done with that one. Next one is only two terms again, and I see a fourth power, and I also see an 81, which I recognize to be a 9 squared. Now if I can think of something to rewrite the b to the fourth that would make it a perfect square, then maybe I can use my quick difference of squares formula. Now I can rewrite b to the fourth as a b squared squared. If I think of it that way, then I really do have a difference of squares, because I have b squared squared minus 9 squared. So let's go apply the difference of squares. I'm going to put b squared and b squared for the two bases, and then for the 9 I'm going to put 3 and 3, and then, or I'm sorry, it's already a 9 squared. I messed myself up there. I'm just going to put a 9 and 9, because remember, perfect square 81 is 9 times 9, and perfect square b to the fourth is really split over 2b squared and b squared. So it would have to be a plus and a minus, and this first piece is prime because there's a plus in between. However, this guy I can factor further. It's another one of those difference of squares, b and b, and then for the 9 I can put 3 and 3 plus minus, and then bring down the b squared plus 9. So that was an interesting one because it was a difference of squares embedded within another difference of squares. Now that's fully factored because I have the binomials split up, and none of the binomials, they're all written as a product, and none of them have anything in common that I can pull out. Next one, I see 4 terms. When I see 4 terms, remember I think grouping. There is no GCF to pull out at the very beginning out of all of them, so I just have to look at them as 2 at a time and pull out the GCF of this mini piece, which doesn't look like, I might have copied it wrong. Yeah, I did have it copied wrong. It should be ax minus bx. So now again, let's look at the first 2 and pull out the GCF, and it looks like the GCF for the first 2 is an x. When I pull that out, I have a minus b left inside the binomial. Let's look at the second 2. Pay close attention to that minus in the middle, because remember we're going to pull that out. Now I pull out, looks like they have a y in common, but a negative y. That's going to leave me with a here, because I pulled the negative out, and then this positive will turn into a negative because I'm pulling out a negative outside, and the y is gone, I have a b left. Now notice they both have this giant binomial in common that I can pull out. So again, what happened was I pulled out a negative y, and I was left with a positive a and a negative b because both signs switched. Now pull out the a minus b, and you'll be left with these guys, x minus y. Now it's fully factored with a product of binomials with no common factors within each of the binomials. Let's go to part D. I see cubes. I want to check to see if there's a GCF to pull out first, and there is no GCF, so I think of this as 3x cubed, and I think of the 8 as 2 cubed. Now I'm going to have my little binomial and big binomial. 3x plus 2 are the bases that are going to go in the little binomial. This is a sum of cubes. Then I'm going to square this guy and get 9x squared at the beginning. Square that guy and get a plus 4 at the end. Remember, switch the sign into the opposite and then squish the two together and multiply them. So 3x times 2 is actually 6x. Put that in the middle and you're good to go. That's my sum of cubes factored into a binomial and a trinomial. And again, this trinomial will not be further factorable, so just leave it as is. Next one, I'm hoping I'll be able to get a product of -5 and a sum of +4 somehow, because the leading coefficient is already 1. So I'm going to put x and x, and the two factors of 5, the only two I have are 5 and 1. The bigger one has to be positive to get a +4, and the smaller one has to be negative so that the product can be a -5. And we're good to go with that one. Part F, I'm going to see if there's a GCF to be pulled out first, and it looks like there isn't. It's a trinomial, so I'm going to move the 3 up and multiply it with the 8. That's going to give me t squared minus 5t minus 24, it looks like. Now I'm going to think of two numbers that multiply to -4 and add to a negative, or -24 multiply and add to a -5. So t and t, and it looks like 8 and 3 will give it to me. The 8 would have to be negative to give me a -5 for the sum, and the 3 would have to be positive. But remember, I moved up the 3 and I multiplied it, so now I have to divide by that 3 and then do any reducing that needs to be done. This is going to become t plus 1. This is not further reducible, so the 3 moves back up and I get 3t minus 8, and I'm good to go. Again, whenever you're in doubt, you can always multiply it back out and you get the original polynomial. Part G, it looks like I have a trinomial, but there might be a GCF in common. It looks like maybe there's an a they all have in common. I'm going to pull that out and be left with 7a squared plus 20a minus 3. Now I'm going to only focus on this guy because the a is already taken care of. It looks like the leading coefficient is 7. This guy I'm going to save for later, and I'm only going to focus on this. I'm going to move the 7 up and multiply it with the -3, so it becomes a squared. Remember the first a, I'm just going to save this for later. And I'm going to end up with a squared plus 20a minus 21. Now I can try doing this simpler problem, product -21, sum positive 20. So the only two that will work are, I guess, 3 and 21 and 1 will have a difference of 20. So 21 and 1, but the bigger one has to be positive to give me the positive 20 in the middle, and yet multiply to give me the -21. So it looks like that's factored, but since I moved the 7 up and multiplied by 7, now I got to divide by 7, both of these guys. And whatever reduces, reduce. Whatever doesn't, move it up. A plus 21 divided by 7 is 3. Move this guy up, that's 7a minus 1. And don't forget what you had saved, the GCF from the very beginning. And there we go, that's fully factored. No more things in common inside any of the binomials. Part H, I want you to think of this as a quantity squared minus a quantity squared. So basically what I have is I have a 5 squared minus this giant thing squared. So I have a giant quantity squared, and then I have a little 5 squared. So this really is a difference of squares sort of in disguise. I'm going to go like that, make him big. So normally we would say a plus b in one of them, a minus b in the other one. We would just look at the bases and yank out the bases and put one of each in the two binomials. I'm going to do the same thing here. I'm going to yank out the bases, x plus 1 and x plus 1, and put one of each in the parentheses. Then I'm going to yank out the 5 and put one of each in the second spots, and that's a plus and a minus. So a plus b, a minus b. Now the parentheses inside don't really mean much, so I'm going to get rid of them. X plus 1 plus 5. X plus 1 minus 5, and then we can combine like terms. That's going to give me x plus 6 and x minus 4, and we are good to go. This thing gets factored into x plus 6 times x minus 4. Another thing you could do here is multiply out or FOIL out the x plus 1. So for example, let's say you did this. Let's say you said, hey, I'm going to clean it up because there's 2 of these guys. That would multiply out to that trinomial, and then you would get x squared plus 2x minus 24, and that would actually factor out into x and x. Product negative 24, sum positive 2, that would be a positive 6 and a minus 4. That would work, that would give you the same thing as this. So you can either multiply it all out and then factor that overall trinomial from this step, or just treat it as a difference of squares. Okay, last one, we got something like a little 9 squared minus this other quantity squared. So again, this is a difference of squares where some base is squared minus some other base is squared. So I'm going to open up my giant binomials and say 9 and 9 in the first spot for the first perfect square that comes, and then n plus 3 and n plus 3 for those n plus 3's that come in the second spot, and then a plus and a minus. So again, I was using a squared minus b squared, difference of squares, a plus b, a minus b. Now let's clean up the parentheses. 9 plus n plus 3 and 9 minus, be careful and distribute the minus sign, minus n minus 3. That's going to combine like terms. These guys together will give me 12 plus n, and then these guys subtracted will give me 9 minus 3, which is 6 minus n, and that's fully factored. Again, you can multiply this out and factor it, and it'll look something similar to this.